During COVID time, we're reshaping our teams quite often. That's where we decided that we need to change our team-centric approach. We started to develop our service-centric approach, where the service is self-contained and it also has its own infrastructure defined in the same repository. The service does not care who owns it. Even if the team that was owning it doesn't exist anymore, it can be easily reassigned to another team.
Hello, everyone, and welcome to the first episode of missionCTRL. Today, I'm joined by Timur Bublik, Senior DevOps Engineer on the core infrastructure team at Tier Mobility. Timur, how's it going?
Hey, thanks for having me. How are you?
I'm doing good. So, Timur, can you please tell us a little bit about yourself? How'd you get into engineering, and just some background for all of us listening?
Right. So, like many other engineers, probably, I started with playing video games, and that sparkled me some interest in computers and stuff like that. Eventually, that led me to studying a bachelor in engineering, not strictly computer science, but it was tightly coupled with it. After which I continued with a master's degree with even more computer science involved. And during my master's, I was also learning about programming and stuff by myself at home, doing online courses, doing some pet projects. And then I took an internship in a startup and got some solid experience with DevOps, with AWS, with Docker, with Kubernetes, and stuff like that. After which, when I finished my studies, I started working in the various AWS cloud consulting companies here in Germany. So I was helping different customers to deliver their cloud solutions, to build, to develop them. And after some time, I decided I want to do something more with more positive impact on society and environment. And that's how I landed my job at Tier, where I work for almost 1 year already.
That's awesome. And Tier's a really interesting customer of ours, but just a really interesting company in general. But in the US, you've probably heard of Bird or Lime. That's kind of the best analogy to what Tier is doing over in Europe. They are a micro-mobility provider. They're trying to help people have accessible and affordable means of transportation. But I think there's some other cool stats, like kind of background stats that you have, Timur, to share.
Right. So like Mike said, we run different vehicles like e-mopeds, e-scooters, e-bikes. And we have over 135,000 vehicles in the streets worldwide. Our customers made more than 80 million trips and traveled the distance of more than 160 million kilometers. We operate in 18 countries and more than 170 cities. We are more than 1,000 employees. And from IT perspective, we run about 300 Kubernetes nodes in production. All our workload runs in Kubernetes. We also have more than 131 terabytes of data stored in AWS 3. We also have other different storage backends, but later about it.
Awesome. And I think the first thing I was hoping to better understand is how is the infrastructure landscape at Tier laid out? And I think you had something to share visually for us. So if you're listening on the podcast, we record these as well video, so you can head over to our website and watch it. I'll also include the link in the show notes.
Sure. Let me share my screen and show you the slide. Here is the diagram that tries to show our infrastructure landscape in a simplified way. I will go real quick from left to the right, from top to the bottom. We start with the most left block, which is the GitHub. This is the central place where all our service source code resides, as well as all our infrastructure code resides. Then going from the top in the next column, which is the Okta. Okta is our central authentication and authorization provider. We have we provide access to our developers and other team members, for example, to Vault, which is our main secrets engine. We give people access to Kubernetes via kubectl, also with the Okta credentials. We give people access to AWS accounts because we operate in AWS. We also give access to third-party solutions such as Datadog and so on and so on and so on. So we use Okta to authenticate humans against our tools and services. Then we have down below with CircleCI, which is our CI/CD tool for building Docker images for our services that we eventually run in Kubernetes, in our Kubernetes clusters. Then we have next block is a Spacelift, is our CI/CD provider for Terraform. So our infrastructure code is deployed with Spacelift. So we deploy Vault resources, Kubernetes resources, AWS resources, and many more. Then we have our cloud, which is currently AWS, the only cloud we use right now. We run our Vault clusters inside of AWS. We run our Kubernetes cluster in EKS. We also use many native AWS services such as Elasticache, RDS, DynamoDB, S3, Parameter Store, and so on, and DocumentDB. Besides that, we also have a set of solutions to give us more control over what's happening in with our services. So we use Datadog for fetching some metrics and logs. We use Sentry for tracing, Grafana for drawing the dashboards. We have Prometheus and a lot of different stuff. And then eventually, when something happens, we generate, based on this data we collect from this observability stack, we create alerts that then land in certain Slack channels, and also that notify our on-call team that something is wrong.
That's awesome. And you and I were going back and forth, kind of trying to decide what we wanted to talk about today, what would be something that listeners would actually find valuable. And one thing that kind of stood out was originally when you guys had set up your approach to provisioning infrastructure, it was a team-centric approach, right?
Exactly. So we had some sort of a team-centric approach from the beginning. With the team-centric approach, we believe that our teams are going to be they're going to be immutable. They are going to own services. Services might come and go, but there's going to be always one team that owns a service, and it's going to be the same service all the time. So we built our infrastructure in a way that we had a repository with infrastructure dedicated to this team and its services, while the service itself had only the service repository itself had only the source code and some Helm YAML files and stuff like that, and CircleCI pipeline definitions. So, but over time, it's a pretty good approach. It probably works for many companies that are more stable from the team's perspective. But during COVID time, we as many companies, we started to change. We also are a startup that is growing pretty fastly. We're reshaping our teams quite often, and we also change the ownership of the services. And this brings some trouble when you try to move a service from one team repository to another team repository. You can do that, but it takes quite some time. That's where we decided that we need to change it. We need to change our team-centric approach to something else. That's when last year we started to develop our service-centric approach, where the service is self-contained. It has still its source code. It still has its Kubernetes stuff, and it also has its own infrastructure defined in the same repository. So eventually, the service does not care who owns it. And even if the team that was owning it doesn't exist anymore, it can be easily reassigned to another team. Let me show you the diagram that better explains this approach. So here on the diagram, you can see that you have, for example, 3 services. And with the service-centric approach, it's easy to reassign a service to another team, or also to give an extra access to a team that doesn't own it. For example, we had a team B that was split into two other teams, and we give them, let's say, guest access to those services A and B. And we also can easily remove the access or ownership of the team A to service C without any of these services ever knowing that that happened. And to achieve that, we developed a solution which is a central repository to register services and manage access to those services to teams. And that's what we call a service registry. The service registry is managing two aspects of our infrastructure, the service aspect and human aspect. From service aspect, we register a Spacelift pipeline or Spacelift stack that deploys that will deploy infrastructure Terraform code stored in the service repository. It does not deploy the service infrastructure itself, but only the pipeline for it. So it will track the service repository to deploy those changes. And then from the human perspective, we create teams in Okta and give those teams access to the services that these teams are supposed to own or to get access to. We also manage observability and responsibility of a team regarding a service by defining the PagerDuty alerts, the Slack alerts, and stuff like that. I have prepared a simplified version of our service registry to show you how it looks like in real life. Let's start our review from the main TF. It's a central file where we will call both teams and services. So we define our services and teams in YAML files inside of those two modules. Let's start with the services module where we have the service configs folder. So basically, whenever a team needs to develop and deploy a new service, they need to generate this one YAML file. What we do is we use a cookie cutter that basically prompts a couple of questions like a service name and the branch and repository that will generate this YAML file for them. And developer, to register a new service, developer just needs to commit a YAML file into this repository. So in this repository, for us, we decided to come up with the next structure, which is the service name and Kubernetes namespace. We specify them separately because we think that there might be a situation where you want to deploy multiple microservices in the same namespace, as well as have maybe a microservice per namespace. Basically, we leave ourselves more flexibility in this regard. We also need information such as repository link because we create our Spacelift stacks based on them. We also need to define the main branch that is used in this repository in Terraform version. These two, together with repository, are needed for the Spacelift provider. But if you are using any other CI/CD pipeline that is being able to be defined in Terraform, those might be different for you in your use case. So basically, after we have defined those YAML files, Terraform will pick them up with a couple of helper functions that we defined in the locals file. Basically, first we are reading those YAML files, going over them with the file set function, and then decoding them. We create a simple map, which is basically a service name equals to all the details you have right here. This is going to be needed a little bit later, as well as here down below, we are further transforming this information. So we need to, basically we have situations where many services are deployed in the same repository, and we still want to register them because they might be in a different namespaces. So we want to give this fine-grained access to teams, that one team can have access to a certain namespace of one repository. And but we don't want to create, let's say if we have one repository with 5 microservices registered in service registry, we don't want to create 5 space-left stacks for them, because it's still the same repository. So that's why we basically deduplicate them by just these 3 attributes. After that, we need to remap them in order to feed this information to our module that will eventually create the space-left stacks. And this last one we have created mostly for ourselves, for our purposes. So just an output of the service names that we have. It really helps during development, but is not really used in this particular use case. Here we have, basically it's a placeholder because we don't know what CI/CD provider you're going to use. We as we said, we are using Spacelift. We have our own Terraform module for that that will deploy the stack and a couple of environment variables and stuff like that. But it could be anything else you want to use. And then we channel this information that we gathered here out of the module here to basically reuse in the Teams module. Going to the Teams module, we again have this YAML config with the team definition, where again we define this structure in a way that fits us. It doesn't have to be exactly the same for you. For example, you might not need this metadata or this on-call flag that we use for ourselves, but probably you would still need the owner and guest. In our vision, owner is there can be only one owner of a service, because if you have multiple teams owning a service, there's this blurred shared responsibility line that you don't really know, or the teams don't really know when is it their responsibility to fix this issue. So we decided that there's going to be one primary owner of a service, but there can be also a guest of a service where you get mostly same permissions from perspective of access to the vault secrets or to the Kubernetes cluster, but with certain restrictions. Again, it could be different for you and your team structure and whole company structure, but it works pretty well for us. So we have this YAML file that we again parse with this local STF, where we first get the list of all services owned in all teams, and then we want to make sure there are no duplicates, because there might be a situation where there's another team that also wants to own this service, and this is against our philosophy, and we want to prevent that. That's why we validate this, and we'll pass this validator into a variable. I will show this later. We don't use it right here, but again, I will show this later. And then eventually we are creating the same map as for services, where there's a team name equals to the old team details. And this file is generated with a cookie cutter, as well as this Terraform file that will take this information about the team and pass it to the module that we prepared inside of this repository. It will pass it together with the service configs that we have exported in the service module, and with our ownership validation. Let's take a look at this ownership validation. It's basically a variable that is only existing to use the Terraform validation block in a variable and throw a meaningful error that there is something, some other team that probably tries to own the service, and we don't want that. Please make sure you're not doing something that we don't want. And then inside we have another locals file that basically it goes through all services that this team owns, and that this team owns and takes the information about this service from the this variable that we again exported here. So it's basically a it's basically a map of all services, and we just need to find the right one to map this information. So basically, this would have the information about service foo because this is what this team owns, and then the same for the guest services. What we do with this information, after all, in our case, we would create an Okta group based on the, let's say, team name and maybe some more metadata. In our case, it would also create some vault roles for this team. And these vault roles would have a vault policy that would allow this team to access this service that is stored in this Kubernetes namespace. Then we also use this information to create an AWS auth operator mapping to basically tell our Kubernetes cluster that this team has access to these namespaces and has these permissions. Again, that's why we are using, we have created this Kubernetes namespace attribute. This also will create IAM roles for these teams, and these IAM roles will have permissions to modify, create, and delete all resources that belong to this service. So we basically control all access of a team to a service from, I think, from all perspectives, or from all meaningful perspective like Vault, Kubernetes, and AWS. They're all controlled here, and team and service knows nothing about it. I think that's a simplified overview. And basically, when you get this zip file, you can also run Terraform init and Terraform plan. This will only output what you have defined, but so only for visibility that it kind of works. And then you can build your own modules on top of that. You can define a main TF, you can run your modules that will deploy your infrastructure belonging to a team, control access for your team to those certain infrastructure parts you have. So this is like a skeleton for you that you could use, or just take certain parts, certain functions, and implement them in your current solution. And again, we generate these YAML files for teams and for services, as well as this TF file for with a cookie cutter. You might also have a different approach.
I mean, at the very least, I think this will be great inspiration for others, whether they want to kind of see what Timur has done and how you guys have kind of approached this and your new philosophy of a service-centric approach. I think it's great inspiration for others to kind of take it and run with it. But I think we're coming up on time here, so why don't we maybe do a quick summary of kind of what we've talked about today and learned, and then let us know how people can stay up to date on what Timur is working on.
We switched to a service-centric approach because it better fits our needs. In a service-centric approach, service is self-contained, and we use service registry to register a service via Spacelift, and we use a service registry to control a team access or human access to the service and its secrets and its underlying infrastructure. On the diagram here, you see that service registry is a central place for us. It's a repository that creates teams in Okta, it creates AWS roles, it creates Kubernetes resources, access in Vault to a service that is deployed, and it also creates an infrastructure pipeline that will deploy the infrastructure from the service repository via Terraform, as well as basically it will only deploy the pipeline, and then the pipeline itself will already deploy the infrastructure belonging to the service. At the same time, we also have a Circle CI to deploy the service itself into this infrastructure.
Well, and if you guys want to stay up to date on everything Timur is working on, you can check out their engineering blog. It's at tier.engineering. I will also add that to the show notes. But Timur, thank you so much for joining me today. Great discussion, and stay warm over there in Berlin.
Thank you very much. It was nice meeting you, and have fun
I will. I'll try. Hopefully we get a little warmer here. It's a little bit too cold for my liking. All right. Have a good one, sir. Bye.
Mission Control is brought to you by the team at Spacelift. Spacelift is a missing layer of collaboration and automation for DevOps teams who write infrastructure as code. If you'd like to learn more, please visit us at www.spacelift.io or follow us on Twitter at spacelift.io.